soil sample. Soil sample plus moisture from 137.63.
This is determination of moisture content from the sample collected from site, and it's been taken to the lab. The project is at level laboratory and field test examination. The date considered is 30th of September 2024. The date of the test carried out was on the 26th September 2024. Type of soil, lateritic soil. The location is at Unical. Then that's the coordinate is UTM. The sample number is 1 and 2. We are going to consider looking for the liquid limit and the plastic limit of the soil sample. Then the container numbers are as follows. For the first one, 132 for 5.9. That's the weight of the container. Then we also consider the weight of the sample and the container, which is 137.8. Consider the weight of dry sample plus container after it has been subjected to oven for 24 hours at temperature of 105 to 115 degrees Celsius. Then we consider the weight of the water content, which is there. Also, the weight of the dry sample is also measured. As you can see, the subtraction. Subtraction is the weight of the dry sample plus container minus the weight of the container. Then we consider the moisture content measured in percentage, which is the weight of water divided by the weight of dry sample multiplied by 100. It is done for the first, and we now consider for the second. That's container number, which is 144. Then weight of container, it continues and continues all the measurements, and you can see it is now taken. So we sum up and find the average. When that is done, we have known the moisture content for the water, for the soil sample. So right now we are taking it back to consider the liquid limit and the plastic limit of the soil sample. The liquid limit is the moisture content at which the soil sample changes from liquid to plastic. At liquid limit, the moisture content, the soil is considered to have zero share. At the liquid phase, and then at the plastic phase, it starts behaving like the plastic. Then the plastic limit is the moisture content when the soil sample changes from being plastic to being semi-solid. So we take that to the laboratory, also consider it. It is now put into what we call Casa Grande apparatus. In Casa Grande apparatus, 25 blows are considered for the groove made there to close up. But it's difficult to have that groove. Since it is difficult, we have to plot the groove at interval, the moisture content at which it closes. Then when you now connect your dots, you now interpolate, then you will now have your moisture content. You have your liquid limit for the very soil sample. Also for the plastic limit, the soil sample is rolled into thin thread of about 3 millimeters. At that point, if it breaks, that's the plastic limit. Then you take it to the oven, dry it, measure the moisture content with the sensitive balance. So when that is done, we now have
Good afternoon. This is another day for the experiments. We continue still with the soil analysis test to be able to grade the soil in a particular group according to the ASTRO. So today we are going to carry out the Atabac limit, where we will have to use the 425 micron sieve to sieve the dry sample that was taken 4 days ago. This dry sample, will take a sieve of it, then mix it with water. After mixing it with water, we will now subject it to 25 blows and to the number of blows that the groove of this Casagrande groove apparatus will make until the groove closes. So we are going to sieve it now. Yeah, we have quantity enough to be used, so we are going to add some portions of water. Okay, after it is properly mixed, now we are going to make the groove with this Casagrande apparatus. First of all, we have to dab the groove in water so that it will not be sticky. It will allow it to flow smoothly through the soil. Now, after that is done, we have to reset the groove with Casagrande to 0. Now, we'll smack it until the 2 millimeter groove closes. We start counting. It closes at exactly 16 blows. So we are going to transfer it to the moisture can and weigh it so that we can determine the moisture content for that very sample. .4 grams with the content. So now this will be transferred to the oven to be oven dry for 24 hours. When it is oven dry for 24 hours, we now take measurement of the dry sample, subtract that of the can, then we repeat the same thing for different moisture content for different glues so that we can have a plot of the water content and the number of glues. Thank you.
Your readings for the containers, those are the containers. Then you consider it and you have your readings all. You consider it is done. To save time, you just record it at once. Then you find the average. The average of it will give you the liquid limit of the very soil sample. Okay, the same thing applies to the plastic limit. Thank you.
Okay, now is another day we have to take the sieve analysis of the sample that was taken from field yesterday. So at the moment we have to take the measurement of these different sieves. This is sieve number 4. Take the measurement of sieve number 4 to know the weight. Okay? Sieve number 4 weighs 3.15 grams. Let me tie it first. Okay. Sieve number 4. Sieve number 4 weighs 335.64 grams. This is sieve number 7, weighs 345.57 grams. The next one weighs 348.77 grams. $357.20 grams. $322.65 grams. This is 304.34 grams. The pan weighs 256.09 grams. Now we start with sieves according to the sieve size, with the finest below. Next to the finest is next. We arrange it. Then we now get the soil sample. This is the pulverized soil sample that was taken yesterday. Now we are going to take measurement of it first before we now empty it to the different sieve sizes. take like 500 grams of it. Let's check. It's beyond the limit of the weighing balance. We now use the bigger scale. Set it to 0 and measure it with the pan. This gives us 9. This is 5. This is 5, 0.5 kilogram, 0.6, 0.7 kilogram. This is 0.7 kilograms. We now turn it to the sieve with the biggest number after it has been pulverized. That's 0. Sample, salt sample is sample 0.7 kilograms with pan. Now only pan weighs 0.15 kilogram. Only pan weighs 0.15 kilogram. Then sample now weighs the difference, which is going to be 0.55 kilograms. So the total mass here is 0.55. We cup it to the cover so that when it is shaken, it will give us the desired result. Put the cover and we strap it. That side is strapped, while this side is also strapped. Then we shake it. This shaking is done for 15 minutes. After 15 minutes, we will now take measurement of the sieve and the content inside. Sieve number 4 with the contents. Contents plus soil sample. This is 347.15 grams. This is the next one with contents. It weighs 366.81 grams. Third, this was 510.78 grams. Let's see. This one is beyond the limit of the sensitive balance. So we weigh it here. And this one.
Okay. This is another experiment. This is for sieve analysis, or you call it particle size distribution. So here we are taking laboratory sample, soil sample from the site. from the field to the laboratory, and the essence is to check how the particle size of the soil is distributed. So in this experiment, we will now consider the date the soil sample was taken, the date the soil experiment was carried out, and the date it was approved. So the project topic is the laboratory and field test examination. So for sample location, it is at Unical, 32 degrees north, then 428036.1, 546673.5. That's for the UTMS coordinate of the place measured with GPS. So now, sample description is lateritic soil, is clay in nature. Then you now measure the weight of sample taken to be measured for 2 different times in grams. By right, it's not supposed to be more than 500 grams to avoid error. So we have the sieve numbers as distributed as it is. Here are the sieve numbers. Then you have the sieve sizes, the numbers with the sieve sizes. The sieve size corresponds to the number. That determines how many different squares do you have in a square inch of the sieve, which means sieve number 4 should have 4 holes per square inch, about 4.75 holes per square inch. Sieve number 5 should have 4 holes. Then that's all the sieve size. So it continues. Then you go to sieve number 60. Then the whole of the size is 0.25 before you get to the pan. So as it stands, we now consider weights after pouring the sample in the first sieve that as you stack your sieve, then subject it to vibration for more than 15 minutes constantly. The particles are now spread and sieved through the stacks of sieve till the final particle settles at the pan. So when that happens, you take the readings and you collect each pan with a sample and measure. When you measure, that's the weight of sieve before the measurement starts, or the weight of sieves. That's how it is. Those are empty sieves. Then you now measure weights of sieve and samples. Those are the things you get for weight of sieve and samples. Those are the corresponding values. Then you now go to retained the weight of material retained on each sieve. That is what you get. For sieve number 4, 0 material was recorded. For sieve number 5, 11.5 grams after subtracting the difference between the weight of sieve and the weight of sieve plus sample. And for sieve number 8, the same thing, the value is 21.2 for the retained material on the sieve. Then you go over to the percentage calculation of those values. It is also displayed there. Then the percentage passing, it is also displayed there. As it stands, you cannot just rely on one experiment. You carry it out for 2 different values, at least, to find the average. So the same experiment is repeated for the second materials. Weight of sieve is already there. Then weight of materials retained on the sieve is also there. The percentage passed, the percentage calculated on sieve. Then you now have percentage passing. Then you now continue to have, as for the next one, they allow it to flow. So at that point, you have succeeded in calculating the retained total and the loss from your calculation. It is now showing. Then when you finish, you now plot this graph called particle size distribution curve. That is the percentage passing versus the particle size. When that is done, you now have your diameter 60, diameter 30 for diameter 10. And when that happens, you can now calculate for fineness modulus. You can calculate for coefficient of uniformity. You can also calculate for coefficient of curvature. That's what you have there. Then for the values that we have, the coefficient of uniformity is fineness modulus is 5.20. Coefficient of uniformity is 5.33224. Then coefficient of curvature is what you have there. With these values, we now go to already set standard by H2 to help you categorize the soil, which has to do with percentage passing and the grid zone. Then the ISC designation is also there. You use it. So the D30, D60, D10 are effective size of particles corresponding to the 60%, 30%, and 10% final in the particle size distribution graph. They are used to calculate the coefficient of uniformity and coefficient of curvature values of the soil. So those are denoted as D10. So as it stands, the coefficient of the uniformity has been determined and the soil has been categorized from the readings that we have here. According to all those values, the soil conforms to grading zone 3. So the soil is suitable for heavy traffic road construction. Greater proportion of the particle lies between 0.3 millimeters and 1.0 millimeters. That corresponds to this zone of particle size distribution. That's the grading of the soil. And this is the result. I want to say thank you. And for more information about it, follow the procedure as it was done in the video. Then you get your results and retabulate, and your results will be okay. Thank you.